I want to start today with a lie. Or, well, maybe let's call it a comfortable myth.
Okay, I'm listening.
It's the story that everyone in data has, told themselves for the past decade.
Right.
That data engineering is basically just logistics. You're moving boxes, you take data from A, move it to B.
Keep the warehouse tidy.
Keep the warehouse tidy, keep the stakeholders calm. It's plumbing.
It was a very comforting story while it lasted. Made everything feel manageable, predictable.
Predictable. That is the key word. Because if you're listening to this and you look at the date, January 21, 2026, that job description isn't just outdated, it's dead.
And it's dead because the consumer, the customer for all that data has changed.
Completely. And that's the pivot for our deep dive today. We're looking at this really fascinating and honestly kind of alarming piece by Samuel Williams from datapro.news.
It's called The Agent Matrix is the Real 2026 Data Engineering Job.
Exactly. And his whole point is that the things consuming your data aren't people with coffee cups anymore.
No, they're autonomous agents.
And when your user changes that dramatically from a human to a fleet of AIs, everything about the architecture has to change. The stress levels.
Yeah.
The whole philosophy of the job just flips.
Yeah. We're talking about something he calls agent sprawl and this new idea of an agent matrix.
It's a shift from being a plumber to being, what, an architect of intelligence.
That's a good way to put it.
So let's get into it. Williams kicks off with what he calls the instinct gap. And I think anyone who's been an analyst feels this in their bones.
Oh, yeah. It's the huge difference between a human looking at a spreadsheet and an AI looking at a database. Think about a human analyst back in, say, 2024.
Okay.
When they joined a company, they didn't just learn the SQL schema. They learned the, for lack of a better word, the vibes of the data.
The vibes, yes. It sounds funny, but it's so true. It's that tribal knowledge that never gets written down.
Exactly. It's institutional memory. They know that the table customer churn final V3 is a trap.
Right. It's full of garbage.
Or they know a certain metric is political, The CEO defines active user one way, the product team another. You have to be careful.
They have a smell test.
They can smell a nonsense joint. A human runs a query. It says revenue, $0 for last month. They don't just publish that.
No, they stop. They pause. They think, wait a minute.
That looks wrong. They go get coffee. They Slack a colleague. They investigate.
But an agent.
An agent doesn't have instincts. It just has inputs.
Yeah.
And it does not handle ambiguity well. If you tell it to join table A and table B, and the result is nonsense.
It will confidently serve you the nonsense.
And probably write a very convincing paragraph about why that nonsense is a brilliant new insight.
And it's not just about being wrong once, is it? It's the scale. The source makes this terrifying point that agents don't just stop, they fan out.
Yes. That's the behavioral shift that catches teams completely off guard. A human hits an error and stops. An agent hits a confusing result and thinks, I must investigate.
So it spins up 5 new queries.
Or 10. Or 50. It iterates. It refines. It just hammers your systems with this uncapped number of questions.
It's that recursion loop. I've seen it happen. You get a compute bill, it's just through the roof.
Because an agent got confused and tried to brute force an answer. So if you're still thinking your job is just logistics, just moving data.
You're setting yourself up to get steamrolled. You'll be on call 24/7, just cleaning up the mess from confident, high-frequency, wrong answers.
Which brings us to the solution, or at least the blueprint for a solution. Williams calls it the agent matrix.
Okay. Sounds very sci-fi. Let's break it down. What is it technically?
Well, it's more precisely the task-to-agent matrix. And the key thing to understand is that it's a structural change. It's a move away from how we used to build things.
Pipelines, DAGs.
Right. Directed acyclic graphs. Step 1, then step 2, then step 3. All locked in. Usually batch processing.
But agents hate idle time.
They hate it. And if you have a powerful AI model just sitting there waiting for a batch job to finish, you're just burning money.
So the matrix isn't a line. It's more like a grid.
It's a grid of tasks. And in a matrix runtime, every single input record is its own independent task. It moves asynchronously. It's not waiting for a whole batch to finish.
So you can have thousands of these little investigations happening all at once.
Huge concurrency. And they're all moving through a chain of what he calls specialist agents.
Okay, that's a key point. Because the temptation, I think, for a lot of people is to build one giant God mode agent.
You do everything agent.
You've got GPT-5, you think, I'll just make it do everything. Why is that a bad idea?
Because it's slow, it's expensive, and it's impossible to control. It's like hiring one person to be your lawyer, your accountant, and your janitor.
They're going to be bad at all three.
And debugging it is a nightmare. The prompt context gets so bloated with instructions for every possible task that the model gets lost in the middle.
So 2026 is the year of the specialist. Decompose the problem.
Absolutely. The standard is breaking the workflow down. He gives a few examples. You have, say, a data quality agent.
Its only job is to inspect the schema and look for anomalies.
That's it. It doesn't answer questions. It just asks, does this data look weird? Then maybe it goes to a context enrichment agent.
The librarian.
The librarian. It pulls in definitions from internal docs. Then it passes to a logic agent.
That's the one that actually writes the SQL or the Python.
Right. And then, crucially, it goes to a judge agent.
I love this concept, the judge agent.
Its job is to verify the output, to critique the logic agent's work before a human ever sees it. This whole decomposition makes everything faster, cheaper, and way more reliable.
It sounds much more robust, but I feel an engineering but coming.
It leads directly to the next nightmare.
Agent sprawl.
Agent sprawl.
So we solve the stupid God agent problem and create a Hydra instead.
That's a perfect way to describe it, because once you admit specialists are better, you don't just have an agent, you have a fleet.
A quality agent for finance, another for marketing.
Because the data is different. A judge agent for legal compliance, another for brand tone. Suddenly you're managing dozens, maybe hundreds of these things.
All with different prompts, different permissions, different failure modes.
Total operational mess. And this brings up a new concept from the article that I think is going to stick. Agentic technical debt.
That phrase really hit me. How is that different from normal tech debt?
Normal tech debt is, bad code, an old library.
Agentic technical debt is when your system produces a bad output.
Yeah.
But because the workflow is split across 15 autonomous agents.
Nobody knows who messed up.
Nobody can trace the chain of reasoning.
It's the Spider-Man pointing meme, but with robots?
Exactly. Was it the retrieval agent that pulled the wrong document? Did the logic agent hallucinate a join? Was the judge agent asleep at the wheel? You just don't know.
There's a quote in here that sums it up perfectly. He says, "It is the same old production pain, but now it speaks fluent English and sounds confident while it breaks things." It's terrifying because it masks the failure. An old pipeline failed with a big red error. You knew. Now the pipeline shows a green check mark. But the agent has written a beautiful, confident 3-paragraph explanation of something that is completely wrong.
So if we have this sprawling fleet of confident liars, how do we fix it? The article pivots here to something called context engineering.
This is the real takeaway, I think, for any engineer listening. Context engineering is not optional anymore. He calls it the substrate.
The substrate. Okay, what does that mean in practice?
It means you have to embed machine-readable, meaning right alongside your data. Remember the instinct gap? We said humans have all this context in their heads.
The treadle knowledge.
You have to get that out of their heads and into the metadata where the agents can read it.
Okay, the article breaks this down into 4 specific types of context. I think we should walk through these.
Let's do it. First up is semantic context.
Business meaning.
Exactly. Words matter. Does revenue include tax? Does churn mean they canceled or just paused? If you don't define this explicitly for the agent,
it's just going to guess. And it will guess based on the whole internet, not your business.
Right. Next is temporal context. This one seems simple, just dates, but it's where a lot of agents fall down.
It's more than just the date on the row, isn't it?
It's what was the state of the world at that time? An agent might compare Q1 2024 revenue to Q1 2026 revenue without knowing you completely changed your pricing model in between. You have to flag that temporal shift in the metadata.
So it's the history book, not just the calendar. Okay, then we have relational context.
Dependencies. Meaningful joins. This is how you prevent those nonsense joins. You have to explicitly tell the agent, these 2 tables can be joined, but these 2 never should be.
You're encoding the guardrails. And finally, quality context.
This is the honesty layer. It's telling the agent this table is gospel, or, hey, this table is known to be buggy, don't trust it for financial reporting.
So you're actually documenting your own messy data for the AIs.
You have to. You can't fix everything overnight, but you can warn the agent. If you don't, it just assumes everything in the database is perfect truth.
This all leads to what the source calls active metadata. And, the word metadata usually makes my eyes glaze over.
Library cards.
Yeah, library cards. But here it sounds like it's the most important thing.
It is life or death for these systems. The old way, a static wiki page that no one's updated in 6 months, that's dead weight.
Yeah.
Agents need metadata that is alive, active.
Reflecting what's true today.
Yes. The source mentions things like behavioral metadata. How is this data actually being used by other agents and humans? Statistical metadata. What's a normal value? If an agent sees a number that's 6 standard deviations from the mean, the metadata should flag that as an outlier.
The analogy in the article is perfect. He says active metadata is the difference between a fleet navigating responsibly and one driving into the fog at speed.
It's a great visual. Without context, your agents are just flying blind.
Okay, so we've got the matrix, the sprawl, and the context to fix it. But we have to talk about money, the bill, because every time these agents fan out, that meter is running.
Oh yeah, the token life cycle. This is where data engineering suddenly becomes economics. And there's a key point here. Decoding output tokens is almost always more expensive and slower than processing input tokens.
So in plain English,
It costs more for the AI to write the answer than for it to read your question. So if you have a rambly agent that gives you a long preamble before the data,
you are just burning cash and adding latency.
right, which leads to this weirdly counterintuitive idea. A longer prompt can actually save you money.
How?
If a longer, more detailed prompt forces the model to be concise and structured in its output, the total cost goes down. You spend a penny on the input to save a dime on the output.
What other tactics are there? The source mentions prompt caching.
This is huge. You structure your prompts, all the static stuff, the rules, the scheme definitions. Your context map is at the beginning. The dynamic part, the actual user question, is at the very end.
And the order matters because
Because the model provider can cache the beginning. It doesn't have to reprocess all those rules every single time. It's like having the textbook already open to the right chapter.
got it. And what about the think and remember pattern?
This is about avoiding re-reasoning. If an agent figures out a key fact, like user X is in the premium tier, you don't want it to have to rederive that 5 minutes later.
You give the agent a notepad.
You give it a simple key value memory, user X, premium, store it. Next time, check the notepad first. It stops you from using a huge, expensive model just to recall basic facts.
Okay, we can't talk about 2026 without mentioning the law. The EU AI Act is fully applicable now. How does that slam into our agent matrix?
It turns governance from a nice-to-have into a legal requirement. The core of it is traceability. You have to be able to explain why an AI did what it did.
And with that agentic technical debt, that Spider-Man meme of confusion, you can't trace anything.
You're cooked. If you can't trace what an agent accessed and why it made a decision, you cannot scale it. You've basically built a black box that's illegal to operate in regulated industries.
So what's the governance strategy?
Least privilege permissions. Treat every agent like it's an external contractor with the lowest possible access. The marketing analyst agent only gets to see marketing tables. Period.
And you need human on-the-loop reviews.
On the loop, not in loop. In the loop means a human clicks approve every time, which doesn't scale. On the loop means it runs autonomously. But you have the logs and the power to intervene. If the judge agent flags something risky, you're monitoring the autopilot.
Right. Okay, we have covered a ton of ground, from the death of the plumber mindset to building a fleet of agents and trying to keep it legal and affordable. The source offers 2 stabilizers for anyone feeling overwhelmed right now.
The first one is simple. Write down your agent matrix.
Actually write it down. On a whiteboard, in a doc, get out of the code.
Explicitly. List every agent, every tool it can use, and your definition of good output. If it's not written down, it's not governable. You need a roster for your fleet.
And the second stabilizer.
Prioritize context first. This is the golden rule. Do not add a new agent to an ambiguous, messy data estate. You're just adding confident noise.
Build the map before you send out the explorer.
Exactly. Build the context, the semantic, temporal, relational definitions. Then let the agents use it. It'll save you so much pain.
You know, what really strikes me about all this is that the job title data engineer is starting to feel too small.
I agree. A bit restrictive.
We started by saying the job isn't plumbing anymore, but looking at all this context, semantics, governance, it feels like the job is becoming architect of context. You're designing the brain of the organization.
That's it. You're building the lens through which the machine intelligence sees reality. If you build a clear lens, you get amazing results. If you build a cracked lens, you get chaos.
That is a fascinating and maybe slightly terrifying place to leave it. The question for you listening is your current data infrastructure a map that can guide these agents, or is it just a trap waiting to be sprung?
Something to think about while you check your cloud bill.
Indeed. Thanks for diving in with us.
Always a pleasure.